Welcome to this lecture on the role of facade technology in deep renovation. The European building stock is relatively old, with more than 40% built before 1960 and 90% before 1990. It is also estimated that by 2050 at least 75% of today's building stock will still exist. This means that if the energy consumption of building sector must be reduced, the deep renovation of existing building is the key to shift toward a low carbon economy. It is also estimated that building renovation accounts for almost 60% of all construction activity in Europe. Moreover, according to a EU study, the actual total deep renovation rate of existing building is very low, with only about 0.4–1.2 of the overall stock, varying for each EU member state. At today's renovation rate, a timely transition of the EU building sector toward climate-neutral level by 2050 cannot be ensured. This also because the vast majority of these renovations do not use the full potential energy savings that could be achieved implementing deep renovation measures. In this context, what is the role of facade in building renovation? Several energy conservation technologies and measures are available, proven, and ready to penetrate the construction industry market. Among the typical set of measures, the renovation of the building facade is a key. In fact, while it represents an elegant component that helps to define the architectural aesthetics of the building, it also has the critical role of reducing the thermal losses from the inner space. In particular, the facade intended as a combination of opaque and transparent elements play a pivotal role mainly in multi-apartment buildings, usually characterized by high surface volume ratio, where the energy transfer through it can reach 70% of the total. As technologies continue to improve, different options become available and easily incorporated into the building facade, such as innovative thermal insulators, high-efficient photovoltaic technologies, or mechanical ventilation systems. Which are the latest facade technologies or solutions available in the EU market for deep renovation? Several are the solutions available, and both the wet and dry construction techniques can be effective in deep facade renovation. Wet construction deals with traditional systems such on on-site concrete casting or brick block walls that are commonly insulated with external layers. In the last decades, the use of prefabricated dry construction methods in partial or complete refurbishment have been largely investigated. Prefabricated off-site construction technologies for envelope retrofit have been identified as a promising solution for increasing together the architectural quality, the construction process, and the energy efficiency of existing buildings toward the nearly zero energy target. Different researches have shown how the industrialized construction process is currently mature all over Europe. The challenge now is to adapt and transfer those skills and the know-how to the industrialization of the building renovation market, for which, at the moment, there is not a consistent and effective industrialized approach for energy renovation yet. What does it mean, off-site constructions? Off-site construction is a terminology that nowadays refers to the design, production, and assembly of building elements that are prefabricated off-site in a different place and then transported to their final location for installation. The practice guarantees several advantages, among which reduction of construction wastage, increased safety, reduced project schedules, punctuality, energy efficiency, and sustainability. In the recent years, the practice has gained popularity, and due to the technology advancements of off-site prefabricated solutions have integrated many other concepts, including automated manufacturing, robotics, modularity, and building information modeling. The facades are also considered as a multifunctional elements, with a combination of several distinct components, such as insulation materials, windows, ventilation machine with heat recovery, complex shading systems, renewable energy technologies for both electricity and hot water production. The prefabricated elements are also often integrated with sensors for controlling the performances over the time and in some cases to adapt the facade to the environmental conditions. In the last decades, a series of energy retrofit by means of prefabricated systems have been developed, improving the overall energy performance of the facade. They can be grouped on three main categories according to their backbone technology: concrete, timber, and steel-based structure. All the solutions are of course characterized by the presence of different layers, where the insulation materials are predominant. Among the others, the use of prefabricated timber structure responds well to both the sustainability and productivity challenge that characterize the construction sector. Wood is a carbon-neutral material and well supports the prefabrication and the industrialization production. In addition, it is characterized by high thermal performance, minor thermal bridges. It has characteristics in compliance to the design for disassembly methodology. Due to the above-mentioned benefit, the prefabrication of building modules based on timber construction has seen an increased interest in the last few decades. The prefabricated facade has usually windows pre-installed in the module and includes membranes for vapor diffusion control and air-tight layer. More advanced technologies and components can be also integrated in the modules, such as innovative heat pump for heating and cooling purposes, small ventilation machine with heat recovery system, and renewable energy production technologies such as photovoltaics or thermal collectors. Several deep renovation examples based on prefabricated elements have been developed, demonstrating the feasibility and the high potential of the concept, in boosting the transition toward a low-carbon economy. However, today, these prefabricated facade solutions still have several barriers that limits their extensive use, mainly due to a more intensive design effort, a lack of appropriated production infrastructure, limitation in transportation, and, more in general, a shortage of skills during the design and the installation. One of the main critical technological issues is related to the on-site installation that require an high experience and specific skill during the connection between the old and the new facade, and between the modular structure of the facade itself. In conclusion, the diffusion of energy upgrades of building facade based on the use of prefabricated, modular, thermally insulated system integrated with technologies for renewable energy production must be a widespread practice in all EU member states. Those solutions can for sure contribute on boosting the renovation rate, helping in reaching the EU decarbonization goal set by 2050. Thank you very much for your attention.